Right. So, hello everyone. Welcome to the Nebula's call, Nebula 4 and Code 2 session. The call is being recorded and transcribed. So, turn on your webcam if you want to, or if you do not want to, it's up to you. What is your preference? And this video, as usual, will be available on the YouTube channel after a day or two. And also, captions are available via Zoom. And again, I remind you that we have the code of conduct and community participation guidelines of the OLS, so which is also applicable to this call. And we encourage everyone to participate and commit to building a community for all and considerate and respectful of each other. And remember that we are in a worldwide community, so you might be communicating with somebody whose primary language is not English, or who is not in the same time zone as you. Some might be morning, some might be after the end of the day. So let's be respectful of each other. And if you experience any unacceptable behavior or concerns, report it to the organizers, Sarah and Gracial, who is here. And also you can drop them to the email mentioned here. And also, if the issue is involves one of these organizers, please mail the other person separately to take it forward. And also, as the graduate the primary ticket, so please write in the roll call whether it is written or spoken rooms for the breakout room. And so that we can assign you better for the format of your choice for the breakout room. So now let me pass on to Gracial about the graduation reminder.
All right, so next week is graduation week already. Congratulations, yay! So for that, we ask you to prepare a 5-minute presentation. Slides are optional. You can play with the format, you do the presentation the way that you like the most. The things that we need a record of your presentation somehow in our Zenodo community. So if you don't have slides, you can just write a report or take screenshots and create some sort of image portfolio, I don't know, and then upload that to our Zenodo community. Pradeep, can you click on this link at the Zenodo community just so I can show how it looks like? Thank you. So this is what it shows when you go to our OLS community on Zenodo. What you need to do is just click on the new upload button on the top right. And then if you're logged in, if you're logged in, this button will be available for you. And then you can just upload your presentation there. I think it needs to be approved by the OLS team, but you shouldn't worry about it. We're going to see that on the back end. This is required for you to graduate. So next week, we are going to send you a feedback form, a final feedback form, where you're going to need to add your name, your ORCID ID, and the link to your deposit. So also, if you don't have an ORCID ID, please do create your account between this week and next week. That's very good for you in general, so that's a good thing. And then once you have this presentation, please take a look at the Fremapads that we have for next week and choose a slot for your presentation. You can present either on Tuesday or Thursday. If you're not presenting, we really encourage you to join the call anyways to celebrate your fellows, your peers. And so here are the links in the Fremapad. We have the links for the graduation Fremapads. Just pick a slot, add your name and the link to your presentation. So we have kind of an order presentation for next week's call. If you cannot attend any of the cohort calls next week, you can send us a recording. You should upload your recording on the Zenodo OLS community as well and add to the Fremapad your name and the link to the recording, because you're going to play that during the cohort call. So please do that at least at the latest on Monday night. So we have that ready on Tuesday. But if you do really need a last minute, you're free to add your name there as we are starting the cohort call. But if you have a recording and you can attend, please do so by Monday. So we have kind of an idea of how many recordings we're going to have and how many presentations. And then once all of that is done, you're going to send the final feedback form, and then we are going to process everything and have the NASA certificates and badges back to you in a few days, maximum a month. We are going through some sort of transitions in the OLS team, so it can take a while, but in about a month, you're going to get your badge. And I think that's all the requirements. And I think everyone attended all the coaching sessions that you signed up for, so you don't need to worry about that. These was the other requirement, that you show up to all the coaching sessions that you signed up for. Any questions about this process, next week's calls? All good? Okay.
Only one suggestion that once you upload, you need to select in the communities, type OLS, so that it will go to the right community and it will get easier accepted your submission within the community, and everyone can see your once we open the community page, your presentations will be here, and others can go there and appreciate very easily.
Yeah.
Okay. If there are no comments, then let's go back to the open code GitHub skill up session. Let me welcome Maryblessing, who will walk us through and help us learn the GitHub skill and what is GitHub and how to use GitHub in our open science journey. So let me welcome Maryblessing. Maryblessing, the floor is yours. Let me stop sharing the screen.
Hey, hello everyone, and welcome to this training titled GitHub for Collaboration. Um, this is the this is the GitHub part of the open code module for the NASA Top Open Science 101 curriculum. Right, so let's get right into it. So for today's session roadmap, we'll be looking at version control. We're looking at GitHub, which is like the key reason why we are having this training, and of course, like why it matters. I will be walking you through certain concepts of GitHub, like the Markdown and README, the pull request, the issue commits, and then some other features of GitHub that I'll touch on briefly. Then we're going to wrap up the session. So my assumption is that one, we're all researchers or researcher data enthusiasts, and we're also new to GitHub. And if you are not, please do see this as a refresher and follow along. Great. This is me. I am Maryblessing Okolie, and I'm a community professional. You find me in communities like the Chaos Community, OES, which stands for the Organization for Ethical Source, the Turing Way, also in the OLS community and RSC conference where I'm helping to organize this year research software engineering conference. Okay, great. So I understand that a lot of us are researchers. participating in this training, in this program by the OLS in partnership with NASA. But there raised certain questions in the previous course on like why should folks like yourself care about GitHub and the version control, about this subject. So the thing is that over the course of your work as a researcher, you are always expected or will be expected to follow open principles. That is, your work process should be transparent. The output of your work should include diverse voices. So that like it's robust and very well useful to the broader research community. And this is a product of open collaboration and inclusion. And it also invites constructive feedback that contributes to the accuracy of the project, and like I said, the robustness of that project, right? Um, then also you have you want to be able to experiment freely, really, like when you are working on something, or let's say, for instance, you are a research software engineer, you are looking to work on a project and you want to be able to experiment freely, try a new approach without like being terrified of breaking what already exists, already works. Um, then lastly, of course, like you want to be able to like say the history of your work over the course of that particular project, right? You would have a need to be able to like go back in time in certain points or checkpoints where something wasn't broken. Then if all of this, sounds like what you want, as a researcher, then GitHub gives you that kind of flexibility, right? To be able to like do all of this and more. But overall, ultimately, data, results, or even code shared openly in scientific research, it brings tremendous value to the broader scientific community and beyond, right? So, with this mindset, then you want to be able to like use tools that allow you do all of this, that brings this sort of value to the broader research community or scientific community. And my hope is that you feel more confident interacting with GitHub as the course of taking this training. Then, you collaborate and contribute to others' materials. Maybe you see someone working on something you really appreciate and you want to contribute your skills, your knowledge. You should feel confident to be able to like collaborate with on other people's materials and on that project that you really like. Then also understand how to set up your own GitHub repository, right? Yeah. So before we dive right into GitHub, which is again why we're here, I wanted to talk to us about version control, right? So what really is version control? So again, back to my initial explanation of embodying the spirit of open collaboration in research. Now you would need tools, right, that allow you to do that effectively, to be able to easily collaborate or safely collaborate on projects, right? And even the projects you are working on, like your personal project, the files will change significantly over the lifetime of that project. And you really would want a way to track those changes. And this is where version control comes in, right? It is the tracking and management of changes to files over time, and this can be called revision, right? So it track changes. That's the first thing you need to know. Every edit is saved with a timestamp, who made that edit, and even a little message on why that edit or that change was made, right? The next thing you need to know is like you will be able to revert, back in time to a previous version. like I was explaining, like you had a point where something really worked well, and at some point something broke in the project. You want to be able to go back in time to see, oh, at what point did this work really fine, and we can restore um, or go back from that particular version. Then also collaborate safely. I have, mentioned collaboration a lot. But yes, version control allows you collaborate with people, distributed teams, which is like working with people in different time zones, and all. So lastly, we'll have the full history. So with version control, you get the complete history of your entire project evolution, and you pretty much know like why things change and who made those changes, right? And so on. Yeah, you already use versioning tools. The term may seem new to you, the term version control. But the truth is that you already use these tools. When you use your Google Docs, the Microsoft Word, and even Framerpad that you have been introduced to in this training, these are all versioning tools, right? But in a much simpler sense. But what happens when project gets really, really complex, right? Beyond the Google Docs, the Framerpad. So now let's meet Mr. Foxy from the fantastic Mr. Foxy movie. I don't know if you have seen that, but it's one of my favorite cartoons. So Foxy is, I use Google Docs and track changes and emailed files and thoughts, and still I end up with this version of my thesis. I have no idea which is the latest. Now, does that challenge sound familiar? Because I used to have the same challenge where I have like different CV for like a lot of roles that I apply to, and sometimes even to me it gets really confusing. Which one is which? Like I'm always having new documents for a particular kind of activity or role or project, right? It's a struggle even identifying which is the latest, which has the latest list of skill set that I have learned over the course of my career. But yeah, like it's a real challenge, right? Now let's introduce Prof. Lunga. Always to the rescues. Then this is a character from my imagination. So he says to Foxy, he says, "Oh, there's a repo for that. GitHub tracks every change, the who, the what, the when, and the why." Right? Um, so with Git and GitHub, which we'll be looking at really shortly, Foxy would get a one single source of truth, complete history, even do safe collaboration, as we have mentioned, and nothing really gets lost. Let me move on now. Right. Now, take a look at this diagram. So just like in your docs, your Google Docs, you have a folder, right? We have a folder. And in that folder, you have a file. And in that file, you have written content, right? Um, then even though there is a written content, what actually happens behind the scene is there is a history of every of the activities done to that particular file, to that folder, being stored somewhere safe, right? Um, so let's also see that this folder it has the plus, which is green, meaning like a folder has been added, and when you see the pen, it's okay, it has been edited, like a content has been added to it. And when you see the minus sign, you know that a file has been removed, like something has been removed from that file. So all of these things are being tracked somewhere, and we will see how. So let's look more into versioning, right? The general way version control, is used is first by initializing a folder. So you initialize a folder on your preferred computing platform with a version control system, right? Then that system automatically now tracks every changes that is made. So it's the version control system, behind the platform that tracks all of these changes, made by you, made by your collaborators, made by your professor, um, whoever. And it also like allows you to work offline and you can, return later with an update or an edit. Great. So so let's say first you write a code or you start a data project, as you would usually do. Then after you have written the first draft of or made some updates to that particular project, to that code, you then commit those changes to the version control system, right? That's the first thing you do. um to so what that does, it now traces some sort of like a checkpoint, right, that you can then revert back to at a later time if necessary to you, right? You can always go back to then add, you can always go back to remove, then even update more to that file, and then you commit that changes again, or those changes again, right? So it's like a cycle, like you edit, you remove or whatever, then you go back, you commit the file to the original file. And if you have more ideas, you can go back again, right? Uh, so now each commit requires you to add a short message, right? So if we look at here, we see that for the version one, a data method was added to a particular file, right? So that text there is the commit message, letting you and the people you are collaborating know what exactly was done to that particular file, if that makes sense, right? So you add the message describing what was done, the changes that was made, and you should know that these messages, they serve as metadata that ensures current and future collaborators, and even the future you, to understand your development process at any given point, right? And all of these are possible really, and thanks to the smart versioning architecture that has been developed. Um, so like I was saying, it's like a time machine. So you go back in time and come forward in time. In fact, let me show you how this works in the framework part that you are already familiar with. Out. To grab the link to the framework part. Wait, it's loading. Okay. So, oh, I think I got the wrong link, but that's fine. This is this is a hands-on session at this year's SSI Hack Day. This is the project for me and my team. Okay, that's fine. We can use this. So what I want to do is to go to this little time button here, and so it's like we're going back in time, and you would see these different checkpoints, and if you drag it, right? If I drag it, you see the different version and the different edits that was done to this file, right? This is the beginning, and we have this, right? If you even play this, it can go like keep showing you like the different edits. And Pharmapad is really amazing. It even, color codes, the different edits with the person who made that particular edit, right? Um, so you see, it's a lot, right? We're not seeing it at a glance because it's a lot of edits. Like it's like about 2,305 versions, even more because it's even up to like a 5,000 plus version. So like it's a lot. So we wouldn't see an instant like the changes being made, but this is what um version control looks like in practice. Yeah, so let me share the screen instead. We'll go back. Oh no, yeah, great. So like that is what version control looks like in practice. Like the time machine you see in the screen, where each dot like you can see at the top of the time machine um diagram as well. It shows a time point of every saved version so far in that particular project, and even with a message that describes what the change was or what change was done to that particular file. Great. So now we understand version control. Let's now go into what GitHub is, and we'll touch briefly on what Git is, right? So GitHub is a web-based platform that is based on Git, right? For code development, collaboration, testing, and releases. Now, what then is Git? Git is the Git is the most yeah, I think it is the most popular version control system for software development, really. Um, it- it's the one that is very popular, and it's the thing that powers or like the version control system works behind Git, if that makes sense. So it's an open source system that is always commonly in use with web-based software hosting platforms like GitHub. And I'm saying like GitHub because there are some other software hosting platforms which we'll look at really shortly, right? And it allows for collaboration and sharing of code and even research materials, right? Um, Ideally, Git is run in the command line, but thankfully, in more recent times, it can easily be used with platforms like GitHub. So we don't have to go to the command line um, to run our codes, to save our files, or whatever. But yeah, my unstructured definition of GitHub is that it's a cloud-based repository where you can store stuff remotely and collaborate with people, right? So I am using the word stuff loosely here because it could be anything, right? Initially, we define GitHub as a web-based platform that is based on Git for code development, but then it it could store other things like the file, your materials, and so much more, right? And GitHub is code oriented, and what this means is that by default, the developers of GitHub um, or the founders or owners of GitHub, they assume that everyone who uses the platform it's writes code or is a developer, right? But what you should know is that the computing tools that have been developed for building softwares are also great for working with letters, characters, right? Numbers. So it is indeed for everyone, and it is for researchers, right? As it is for software developers, right? For your awareness, as I was saying, it's not just GitHub. There are other online platforms for code management, for collaborations, such as the GitLab, the Bitbucket, the SourceForge, and even much more, right? But for the sake of this training, we are talking to you about GitHub. And also, good to know that it's not open source, like GitHub is not open source, right? But platforms like GitLab do have the community edition, which is the open source version of GitLab, right? And SourceForge is definitely open source. Um, so you don't have to use GitHub, but it's one of the popular ones and widely used by a lot of teams really. So it's good to know. Now, we have talked about version control and how that powers GitHub. We've understood what GitHub is, and now we'll be looking at what GitHub offers. Now, GitHub offers a remote repository repo, as you would probably hear me say it going forward, to store your files. It offers easy way to develop and share materials, but not the only way, I have to mention, because there's also Zenodo and yeah, other places like the Jupyter Notebook that you can develop research. So yeah, it also offers a way to track every change of your project files. As we have been saying, you can see who changed what, when, and why. It offers safe collaboration with distributed team, mentioned this before. And it also gives you project management features for organizing your work, for organizing your projects. Great. Now we go into the concepts. First, we have repository repo again, which we have defined to be a storage location for data, results, code, and even compiled software, right? And we have the readme.md. This is another concept, which is a landing page for your repo. It tells the visitors, collaborators, what your project is about. Then we have the Markdown, which has the .md extension, and this is a simple text formatting language used across GitHub. Great. So this is what a repository looks like. These are all the functions it has, from identifying what the username of a repository is to the name of the repository itself. Then you have the code, which is like the landing page of your repository, right? Then you have the main, which is like the branch, right? Which always shows you like the exact branch, because there's a possibility of having more than one branches on your repository, right? So, but this shows you like the exact branch that you are currently on while you're working on the project, right? And you can definitely see the number of branches that you have. For here, we see one. Um, then you see the readme.md, and we have trial repo. That's the only content we have there. And a couple of other things that we'll be looking at, some of them in the course of this this training. So let's talk more on Markdown. Again, we say it's a simple text markup language, and it's made for quick writing, formatted text, for quickly writing formatted text, and great for a bunch of things like blogs, documentation, and so on. The Markdown can, like it has different headings, right? As you can see, in the screen on the right hand side. So you have the heading 1, 2, 3, and this goes on down to 6. Really, like, someone thought it was really nice to have just 6 heading, and that is fine because I don't know what we'll be doing with more than 6 headings tonight. But you'd see the text, the heading rather, and you see like the display on the other hand, like what it looks like. The heading 1 is more bolder, as you can notice, the 2, 3, and it just keeps going down like that, right? Just like you're formatting a text in your Google Docs. Then you have the bullet point and so much other things that you can easily, format your text with on GitHub. Now let's look at the README files. The markup language, which is Markdown, is what we use to write or put together the README files, right? An ideal README file should include what the project is, why you built it, how to run or use the project or the software or the tools if you were writing or developing a tool, and really any technologies used and installation procedure, right? Usually a lot of README you find on GitHub. This is like ideally what it covers in a glance. It could put more, but yeah. So we also have the Markdown quick reference on the left side. So again, we can see it has the heading 1, 2, all the way down to 6. And with the asterisks, you can have a text bold or italize a text, um, put a bullet point, or you number them, and you can add a link with the brackets, right? Or you can have an alt text, having an exclamation mark in the beginning of the brackets. Then of course, like the text, between the brackets, right? So I think the next thing we have is the demo. Mm, yeah, demo. So we are going to now walk through the GitHub concept that we've learned so far in the part 1. What we'll be doing is we would create a GitHub account. So like pause now if you don't have an account, and I am going to go to github.com. Please follow along. Okay. I'm trying to open the tab. Um, oh, great. Hi, I'm sharing now. So we are going to be signing up to GitHub together. And again, go to github.com and this interface shows up for you, and you find the sign up button at the top right. Yeah. And what we want to do, you can either sign up to continue with your Google account. Um, I will, yeah, I will not do that. I'm going to stop sharing briefly so that I can put in my details, and um, we can then continue. It's coming up, and now we want to sign in again. Hey, our account is now ready for use. I'm going to go back to share my screen briefly. There for a moment. Let's share this. Okay, so we have a fresh and new account, and there is really nothing here. So what we want to do is now, oh, it already says to create a repository here, but it's fine. I am going to go through this, going to go through here. Yeah, this is really empty. Whoa. See, I just named it MV practice, really. So now I come to repository. Of course, like I could have just clicked repository from here, but it's fine. So we do the click on the new at the top right of the screen, and as we saw in the, let's see, if you saw in the slide, we have the username, so, and then we have the repository name. So this is what we are going to do. I'm going to break down the process of setting up a repository. So this is the username, MB Practice, and usually when you are part of a different GitHub organizations, you'd see like a long list here. But like it's just me, and yeah, I'm going to put the so we are trying to help Mr. Foxy, right? So we're going to call it the Foxy Rescue. I think use the hyphen, yeah. Rescue jets. And this is available. Great. So the OLS Nebula open code to practice repo. Great. So this description allows I, it just allows you to give more details about what this repository is about. Really nothing very serious. Then when we go down to the configuration, we have the choose visibility, and we have two options. You either put it to be a public repo or a private repo. Now, if this is private, nobody gets to see this repository. And going back to the embodying of open science values and principles, we had talked about open collaboration. We've talked about inclusion. So you want to include more people in your project. If that's your goal, then yeah, make it public. So you can easily just toggle this on and it adds you a README file, but we are going to create that manually. So the next is the git ignore, and so this is nothing much serious, but what you need to know is that it pretty much just tells GitHub which of the files in your repository it should ignore, right, and not track. Literally, like self-explanatory. Then we have the license, so you should add licenses. I bet this has been covered in one of the trainings by one of the awesome experts that has come on here. But from my little understanding, right? I not an expert in licensing, but I like to think of licenses as legal binding document, just the way in communities you have the code of conduct that tells the members what to and not to do in the community. In licenses as well, it's similar, right? You'll be able to like let people know how they can use your materials, your files, and so on. So we have the permissive licenses like the MIT, Apache, and you would see that here now today the MIT license, there's the Apache license. those are like examples of the permissive licenses, and we have the copyleft licenses like the GPL, right? So this pretty much is saying use it, change it, share it. But if you now build on it, your version must also be open under the same term, which is listed in the GPL license, right? And the one usually for non-code development and encouraged for researchers like yourself to use is the Creative Commons, or in short called the CC licenses, right? These ones are for documents, not code specific, data, images, and your papers, right? Not code specific, not software, right? So this literally is saying use my work, but just credit me. Like give me the credits, like credit me if you use my work, but use it. And I don't mind what you use it for, whatever, but just let me know like you have used it, right? Um yeah, so there is a particular kind of Creative Commons license that is usually used across the research communities, but for now, this is not on GitHub, so we just pick this zero version one, the universal one. So, and we will create our repository. Great. Now our repository is live and this is public, and you can see the about, which is where we put the description early on. And yeah, because we picked a license, GitHub already added the license file, which is done with a markup language again. And we can easily edit this when you figure out, oh, you want to change this license. But please don't change it when you have something seriously going on and people have used or remixed your work, because then that changes affects every other thing, right? So it affects every other thing in the downstream. So if you are going to do the change, make sure you have a clear plan on how to communicate this with people that have taken like used your projects, remixed it, and all of that stuff. So yeah, like we are supposed to just add a readme, but we are going to do it manually, like I said. So we're going to go to add the file, right? And let's see, let's see. I think there's a part where I sort of like, yeah. So the next thing we want to do is definitely create the readme, right? So before I add the file, let me just put up here what will be included in the file. Great. So this is what we include in the README file, the project title, and I think I have a little note saved somewhere that will just make this a lot more easier. We copy and paste so that we can move really fast. Um, okay. So going back to this, we're going to click on files and we're going to do the create new file, right? Um, so we are going to name it Mr. Foxy Rescue Project. Yeah, like no. Is that what we want to do? Foxy Rescue Project. Okay. So we now have this, right? But again, remember the process. you add the file, you make an edit, then you commit the changes. Now you can already see the commit changes at the top right, but we're not committing the changes yet. We are going to commit everything at once, but let's do some quick edits, right? And we are going to do this. Oh, mistake. So we did not add the .md, which means that GitHub did not recognize the file to be, yeah, it did not recognize the file. So when I did the preview, this did not really come. So yeah. So you have to always have the add the .md extension, which tells GitHub that this is a markup language, or this is a markdown rather use that is using the markup language. So you always have to. If you don't, it's not going to recognize it, and this is what happens when it doesn't. You try to preview, and it just stays like this, like there is no real formatting to it, right? But if you add the .md, we come to preview now, then you see it looks a lot more better, and we don't see the ash or the funny things that happen in the background. Great. So now we have identified that this is Mr. Fox Rescue Project. What do we want to do next is we said we would let me share this. So next thing is the one-line description of mission of the project, the next the problem, solution, and plan. We probably don't have all of that figured out yet, but that's fine. We're just going to add what we have figured out. Again, I have this little note, so I am just going to keep. I'm going to just copy and paste most of what I already have. So we are going to. I think we want to. No. Great. So we have the mission. Let's see how that looks like. Let's give it. Yeah, it's good. I mean, not really good. The next is the problem. Like I said, I have some notes, so we are going to just keep copying and pasting like that. But now we want to have it in the heading 2. So we're using the double hash, right? Great. Problem. And we want to put the bullet points of the list of problems. And we have this. So if we try to preview now, we have something like this. Great. Yeah, I think this should be a heading 2 and not just there, because then it looks a little out of place. Great. So I'm going to jump this a little, and we have the collaborators, right? So what we want to do with the collaborators is to add the list of people who are collaborating on this project to help rescue Foxy, really. So I think I want this to be in the, and this is how you make a table. So we are going to be using the table. The reason there's this left and hyphen dash 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 is just that they're like It's just so that the table, the alignment, yeah, like so let's try something, right? If you don't put those things, just so that you have a look at what happens. Yeah. See, it doesn't really recognize that it is a table, and it just, just does the edits and formatting whichever way it pleases, right? But if we add this, this, and even add a column so that it's more aligned, sort of. Well, let's see now. See, it is now a table. It recognizes it to be a table. I'm just going to do this, and yeah. So if you want to add another row or column, you just this, then maybe add a person. I'm a collaborator. My role, advisor, and my superpower. I don't know. Do I have a superpower? A superpower really like maybe, yeah, like what of chaos. You want to have this, but I have an existing node of Foxy and Prof, so I'm just going to put that, and we see what the preview for that looks like. Okay, great. Lead researcher, mentor, advisor, and so on and so forth. Great. Um, um, yeah, that's pretty much it with the editing, the formatting. So there is even like some cheat sheets on, um markup language, right? There's a cheat sheet for markup language, like the markdown. So you can, look more into that if that's really interests you. But I think our repository is coming out really nicely. So what we'll do now is to commit changes. Now, so this commit changes, Copilot would usually, help suggest certain commit messages. It does a really good job, but sometimes you want to double check. Um, then you can now extend the description of the commit message. So, get that a project. Okay, the project for needed mission and problem statement. And these operators. There is a there is a feature, uh, or better still, like a tool that you can use to, aesthetically, and in a very fun and friendly way, list your collaborators on your GitHub repository. But we'll not be going into that. So, um, now I want us to take a look at these two things: the commit directly to main branch and create a new branch. Now, remember, we talked about having the main branch, and then also like the particular branch that the project is on, right? So currently it's on main because that is how it is by default from GitHub. And I am just going to commit to the main branch. but I will explain why later on. Oh, this is taking more time. Okay. Maybe we'll just move on. So the next thing is now Foxy has been able to get like his files, his project organized to a great extent. Then he tries to collaborate, and here are three different case scenarios where Foxy tries to collaborate on people's project. Like he found a typo in a colleague's project, was scared to touch their code. Now remember, version control, GitHub allows us to safely collaborate with people, so we shouldn't be scared. Then his collaborator, they edited the same file at the same time. Now what happens? There's usually an error that throws, but like there's a way to manage it. Then yeah, Proflunga said all three problems solved with fork, the branch, and the pull request. Now this is where it gets more exciting. So we are going to actually this yeah. So this is the pull request flow. You have a fork or a branch, right? Then next so when you use a fork is if I go to another person's project, let's try to search for what have I done? I think it did commit. Great, okay, it commits. Okay, great. Let me try to search for Maryblessing, which is my other GitHub account that I use regularly for work and things. Um, Please allow me to turn off the um, the camera just for a moment. The point where you fork a project is when you try to collaborate on that project, right? And you make a copy into your own account. And I was originally demonstrating here how to pretty much do that. So I am going to share my screen again to show the GitHub page. And I was already searching from my other account, which is this. So I am going to open that up real quick. And this is me, my main GitHub account. Oh no, what am I doing? Okay. I want to come to um this person's repository, right? So they have 26 repository. I have 26 repository. So what I'm going to do is I am going to come to this project. This is the first project the repo for the previous cohort. So let's say I find this project very interesting and I want to contribute to it. So what I do is I come to make a copy to my own account. Now remember, I am currently in Maryblessing's GitHub account, which we are assuming to be someone else. So this is what we do. The act of making the copy to my own account is called forking. So I'm going to find the fork button, and I am going to click on that. And yeah, like the details is fine with me. I'm going to copy to the main branch only. That's literally the only option, but yeah. And I'll create a fork, which is I'm creating a copy of that project into my, right? Great. So now, you see what changed? So before we had Maryblessing and then the Foxy repo name, but now we have MB Practice, and we can see this little fork icon here showing that it is a copy. And now you can even see it more detailed. They said forked from Maryblessing / the repo name, right? So if I come to my account, I do not only have the Foxy Rescue Project. Now I also have the Mr. Foxy Rescue Project 1, which is the copy I have made from Maryblessing's account. Does that make sense? So now if I want to branch, branching is always possible when the project is yours. If I go to Maryblessing's account, I cannot branch from there, right? It's GitHub is going to prompt me to create a fork. So just better to save yourself the stress. But if it is your project and you have like direct access on that project or that repo, you can come here and you see the list of branches, and I can do patch, and I type it, GitHub don't find it, it prompts me to create the branch patch from main. So now I can create patch. Um, oh, I see. So we made a mistake. So I'm just going to rename this. We were supposed to change the name, should be readme.md. I was wondering why it didn't show up in the. That's fine. So we just I'm excited we are making these mistakes together. Yeah, the readme.md. So I'm going to commit this change. And yeah, so this is Copilot doing this rename. So I'm just going to, yeah. So now, yes, this is a perfect example of the branching. So now, because previously when we did this commit, it says commit directly to the main branch, right? But I created a new branch called patch, and because now let's go back. So because the project now is on patch, right? It's asking me now to create to commit to the patch branch. But if I change this to main, when I try to make these edits, I'm just going to do CC, nothing serious. We're not going to be committing it. Then it tells me to commit directly to the main branch. See? So we're going to go back to the patch, and what I want to show us with the patch branch, like having a new branch, and how the PR flow works with branching is, so now I commit the change, and now I commit directly to the patch branch, right? So now let's see what happens. It is renamed. Now I tell you why it is renamed. While it is renamed, right, I have to make a pull request. It is renamed, but I have to make a pull request. So now I get this banner up here saying to compare the different file changes and pull requests. So now I click on that, and then I can change this, but it's fine. It's really fine. So I create the pull request. And see, there is no conflict. And because this is my repository, I have the right to merge this pull request. If you were trying to collaborate on someone else's repository, this option would not show for you. It would rather tell you that you don't have the merging rights to this particular repository. Right now, before the merging, we can see some other options at the right hand side here. So this is very important for different reasons. With the labels, you can add a label to, maybe you were working on a bug, say it's a code or a tool, maybe it's a data management plan to the particular project. You can have a DMP label, and you can easily come here to label it as such. Now we're going to be coming to the commit and a bunch of other things we see here, but this is ready to merge, and I'm going to go ahead and merge it. From merge. Great. So our little contribution is now merged. I remember when I said that the code is, the way I see it, the landing page of the repository, because now we are pull requests, and when I click on code, it takes me to the main page. So now you see that when I rename this to README, it automatically shows here, right? GitHub no longer prompts me to add a README because there is an existing README.md file that it has detected, which is intelligent system. However, it does that. And we can now see that the branches is 2 and no longer 1. So we can either move from main to patch. Now, to explain this, if you remember that part of the scenario was that Foxy is scared to touch the collaborators or the colleagues' code, right? And the prof says, these 3 problems can be solved with either Fox, the branches, and the pull request. Now, we have seen both how the fork works, the branch, and the pull request. We've seen all 3. What I wanted to highlight real quick here is that with the branch or with the fork, you see how I made that changes, or how I made those changes, and I made the change to this with the branching, and I was able to merge it, pull the request, merge it, right? And there is no issue because this is my repository, right? So the reason it prompted me to pull request is because the branch it is on, it's not the main branch of the project. So until that pull request is sent and merged, it won't reflect in the main page. It won't reflect in the original file or in the original project. Let's now see it the other way. If I would open up my other account real quick. Now we might not be able to see that, but what I will do is to try to send a pull request with my other account. Right. So now with what I was explaining, when you try to collaborate with others or others try to collaborate with you, they go through the route of making the copy, which is the forking. And when they do, they make changes, they send you a pull request. So what has happened behind the scene is that I have Maryblessing, I have used my other account to make an edit to these projects and have sent in a pull request. Now, when I share the GitHub screen, what you see now is one pull request had just come in a few moments ago. Now we would check that and we would see. So this is the pull request. It says add contribution guidelines section. We'll check in a moment what Maryblessing has sent in, but let's move on here. So again, with the pull request flow, you either do the fork or branch, you make the changes, you commit the changes, you open a pull request, then a review is done on the pull request and it is merged. If the collaborator on the other end is satisfied with the changes that has been made to that particular project or file. So Foxy says, so I can suggest changes without breaking anything. Absolutely. You propose the changes with the forking or branching method, they get reviewed and then they get merged. Nobody's work is overwritten, right? So you remember when Foxy was trying to really scared that he would break the colleagues projects, or that he would mess it up. Oh, I want to try a wild idea, but I don't want to mess the main project. With branching, they don't have to do that. They wouldn't even be able to do that because now they have a copy, they make the changes. I do not even know when the changes was made, right? All we can see, or we could see, is that a pull request has been sent in. Now, when Maryblessing did these changes, she did not have to notify me. I did not have to know. But I know that someone loved my project and they have made a contribution based on their knowledge, their skill set to the project, and they have sent in a PR, which is a pull request. Great. So we'll move on from here. So now this brings us to the GitHub concept part 2, which we have been talking about in the past few minutes. So we have fork, the copy of someone else's repo to your account, the branch, a parallel version within a repo, as we have shown, where you not try the new ideas that you have without breaking the main thing. Then you make the commits where you save snapshots or versions of your changes. And then you make a pull request where, they're pretty much saying, hey, MB, I made some changes. Can you review and mesh them in? That's exactly what is happening here with Maryblessing sending in her contributions. Great. So we are going to move to the next part to talk about issues versus pull requests, right? So with issues, you're starting a conversation even before you make the contribution, right? And you can add feature tags that needs to be worked on with an issue. Is a feature on GitHub. We'll be looking at it briefly. You can report bugs or errors, propose a new idea of features, save notes, or invite discussions within a project. So a good practice is that you label them for easy sorting, but not too much of a problem, but it's a good practice that you should be aware of. Great. Then with pull requests, what you are doing is you're proposing a specific change or merge. But with issue, you're proposing an idea for discussion or for it to be worked on. But with a pull request, you already worked on it, you've already made the specific change, and you want it to be part of the main project, which is not where it is now merged. All right. So this is the part I wanted us to get in real quick, which is commits. So we are going to touch really quickly on commits, and we'll see what changes Maryblessing has done to our project, right? Ta-da! Commits. So this is commit, and just like I've explained, there is both good and not so good commit messages, but again, shouldn't be something you worry so much about. And then we will look at this briefly now, what we see on the screen, but now you understand how to write a good commit message. We have done that while we did the initial demo, and yeah, so let's now go into the pull request that was sent to our projects. Great. So we talked about issue and pull request, and this is the issue. There is nothing here in the issue. And how you create one is you go to the tab, you click on create an issue and the new issue button, then it shows up here. But for now, there is none, but we have one pull request, and we are going to open that up and see what's inside. So this is the pull request from Maryblessing, and we can see the entire conversation here, which there is none started, but Maryblessing has said that she added contribution guidelines to the README. Great. I've seen that. Now what we want to look at is the commits. We want to see the exact changes that was done to that file. So now we'll go to commit and we click this, and this is what we see. This is the changes that Maryblessing has done to this file. We're going to dismiss this. So she did not delete anything. Otherwise, we would have seen the red mark or highlight instead. But what she has done was to add more content, which is really good. I love this. And if I am satisfied, I would go ahead and merge this by clicking on the ready to merge. However, if I am not satisfied with this, which brings us to the point of discussion, right? Which brings us to the point of discussion, right? If I don't like this, I am going to simply come here to submit a review for Maryblessing. Now let's see this. Oh, this is great. Can you include the wood? Okay. Can you include the specific adjustment that the computer needs to make? Yes. So I am going to now comment, right, for Maryblessing to see. Because I am not satisfied, I am leaving a comment here, and I am going to have her go make this edit. But if I am satisfied, but then want to also approve, then I would go ahead and do this instead. But I think what I'm doing is even requesting a change and not just a comment. So if it is a comment, I would have just said, this is great, and I leave it as that. Awesome. And but I am making a request, so I'm going to use the request change, and I am going to hit the submit review, and we'll see how that goes. So it's going to come up in the conversation section, right? So it's, you see, this is my own comment now, and a change was requested, right? One requested change by me. So what Maryblessing can then do is she can give me a moment, please. Okay, great. So Maryblessing has gone ahead to make the edits that I requested. So let's see what changes that was done to this. New changes since you last viewed. So she updated this. Now let's see what update that is. See? So now, because I said to be specific on the kind of change, we can now see that this line, although it shows red as though it was deleted, but what really happened was that a few more words or letters was added. So she said, like adding your name as a collaborator, which seems good, and I am happy with it. And what I am going to do is I am going to leave a comment, but also approve. Looks great. So I'll submit review now, and the next step is to merge the pull request. Great. So merge pull request 2 from Maryblessing May. Doesn't do much. So what we're going to do is merge pull request on on um on 3 let's see projects. So I would confirm this merge, and voila, this is now merged. And again, if none of us were happy with the changes, we can go on and on with sending a review or adding comments until we are both satisfied with the whole thing. Then what happens now is that this has been merged, and when we come back to our README file, we can now see the how to contribute section, including the more specific way of making the adjustments. Brilliant, isn't it now? So, I wanted to touch briefly on the on the commit. So, if you look at this, if we talked to like talking about the commit, so if you come to this time like icon here, you will see 7 commits so far. And just like with the pull request, you will see the details of every of the commits. You remember when we said that you have a snapshot of every of the changes or versions. This is exactly what we mean, right? So at this time, 1 hour ago, the initial commit was made, this was done, this was renamed, and so on and so forth. And we definitely will be able to see the people who were involved in each of these commits. And again, comes the commit messages, helping us to understand what was done at every given point in time. And even when we leave this project for like 5 years, we come back with the commit messages, we'll be able to know exactly what change was done to this project. So it's helpful for both your collaborators and even your future self, so that you don't confuse things or mix things up. Good. So that's commit. If you opened it up, you would see more about that commit, just like before, the exact thing that was removed and what exactly was added. Great. So I am going to share this, and we've covered commit. So congratulations. Yay. You now know commit, issue, swap, and pull requests, and even how to merge both your own projects and merging changes that come in from your collaborators and even contributors of your projects. So now we have the Foxy transformation. What has happened now is all of this chaos, which is the before, and now we have the after. So Foxy has one repo now, which is now always up to date, collaborating via PRs, with reviews when necessary, easily fork a project, to be able to experiment and make changes. Then you see the full history of every change. You see the snapshot of every change because it tracks it. Thanks again to the smart versioning system that we have. So now you're not junior anymore, dear Foxy. Now go break things responsibly, of course, in branch. So there is more to explore on your own, like project boards, labels and milestones, which we did not cover because of time, how to add collaborators, more on licenses, because this is very, very important. When you don't add a license to your project, you're pretty much saying no one should use the project, meaning it is not easily accessible to people, which is not the kind of values that we embody within the scientific ecosystem. So you want to learn more about licenses, find out the ones that suit your kind of project more, whether it's data or whether it's code. And of course, always include a contributing.md. Now, for instance, the contributing guideline that Maryblessing sent in could have been a separate file on its own, named contributing.md file. We should have the list of ways people can collaborate or contribute to the projects. But it's fine. Now you have more to explore on your own. So congratulations again. This has been really amazing. I hope you picked a thing, two, or more, and I hope this really helps you get more familiar, confident with using GitHub, understanding better what version control does and can't do for you, and stop having different versions of your files. Have a project on GitHub or similar platforms and get organized. This is the reference and the resources that I used in putting this together. So feel free to look them up. And if you've got questions, feel free to ask in the OLS Slack. And thank you to OLS for the amazing opportunity, and to the Turing Way book, and Cassandra for the inspiration in putting this material together. This slide is on the OLS communities and Noodle, so feel free to go grab it at any time if you want a refresher. It will be there. So thank you all for staying through. I hope you're able to, do more with GitHub moving forward. Yeah, it's my pleasure.
you, Maryblessing. So let's proceed to the closing session. We will not hold you for long, but it would be great after you have a little bit of stretch break, coffee break, tea break, and depending on the time zone you're in. So you please write your thoughts on what you have learned today in the GitHub learning session and what kind of things worked out and also what could be improved. And also, thank you very much for bearing with us while we navigate the infrastructure issues unforeseen. Well, thank you very much, and please give your feedback in this section so that we could share the learnings for the next sessions in the next week and later this part of the week. And also, we have the next cohort call on Thursday, July 2nd at 3 p.m. UTC. And also, as Gracielle introduced us to the graduation ceremony, right? Please go and register and also sign up form for the coaching sessions is here. And please review them after a little bit of break for yourself. Thank you very much for joining us today. And please let us know if you have any questions in the chat. We will be around for a couple of minutes, and that makes our session formally concludes for now.
Thank you, everyone. See you on Thursday.
See you, everyone. Thank you.
Everyone.
Thank you. Bye bye.